this video we're going to look at combining vectors. So if we start off with a vector, I shall call it A, and we're going to give it a size of 3, 4. And we have another vector, B, and I'm going to give that -2, 3. Remember, it doesn't matter where you start your vector. You may at times be asked to combine vectors, and you might be asked to do it graphically. So if we have a start point, and we're going to move from that start point 3 on the x, 1, 2, 3, and 4 on the y, 1, 2, 3, 4. We're going to join them up. And that gives us a vector A. Remember your arrow? We have another vector here. We have -2, 3. If I wanted to add A plus B, I would add this vector onto the end of my previous vector. So A plus B, I draw A, and at the end of A, I then start to do B. So I'm going to do, really should have drawn that A on the other side of that. I'm going to come back 2 points on the X, and I'm going to go up 3 on the Y. I have not drawn this in a good place at all. So 2, 1, 2, 3, there we go. And join them together. And that is vector B. So what I have here is A plus B. And that will give us a third vector, which is the direct vector from our start point to our end point. And that is the vector A plus B. Now what is our vector A plus B? Well, it goes 1 in the X and 1, 2, 3, 4, 5, 6, 7 in the Y. But I didn't need to draw it to get that information. You will from time to time be asked to draw them, so it is certainly worth practicing. But I can look at my original numbers and I can say, okay, A plus B is going to get me the actual values, 3 plus -2 and 4 plus 3, which gets me a final answer of 1, 7, which is the same as we did graphically. Another way we can combine vectors would be to multiply them. We call this a scalar. You're adding on repeatedly the same vector. So if I had 2A, what I've got is A twice. So I've got 2 times 3, 4, which is 2 times 3 is 6, 2 times 4 is 8. Now we never say that we're dividing when we deal with a vector. what we do say is that we're multiplying by a fraction. So if I had, say for example, a new vector I will call C. So if C is the vector 10, 6, and I wanted a half of C, I would do 10 divided by 2 and 6 divided by 2. So I'd have 5, 3. Never forget to put your brackets in. These are critical when you're dealing with vectors. I can also subtract vectors. So we've added, we've multiplied. We multiplied by fractions, which is similar to dividing. And our final step is to subtract. So if I have vector C, subtract vector B, C minus B, that gets me 10 minus 2 and 6 minus 3. Remember, minus is a plus. So I have the vector 12, 3. So your normal rules of multiplication, addition, subtraction and division or multiplying by fractions work. Now this is me showing you it in 2 dimensions. I've shown you an X and a Y. The same works in 3 dimensions. So if, for example, I have a vector call it T, and we're saying that T is a 3-dimensional space, so 3, 4, 5 for the sake of argument. That would be our X, Y and Z coordinates. And we wanted to add on a vector S, and that was 4, minus 2 and 5. It's gone, this T has gone 3 in the X direction, 4 in the Y direction and 5 in the Z direction. Now usually when we think about how we plot these, X is still going left, right, Y is now going back and forward, and Z is going up and down. But we can still combine them in the same ways. So if I did S plus T, I would have 4 plus 3 is 7, minus 2 plus 4 is 2, and 5 plus 5 is 10. If I were to do 2T, I would get 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. If I was to do 2T minus S, I know 2T is 6, S is 4, so 6 take 4 is 2. 8 take minus 2, that makes it 8 plus 2, so that's 10. And 10 take 5 is 5. And that is combining vectors.